Alright, welcome back. Yeah, now there is a condition where you can't use this Pascal's triangle method for your binomial expansion. The condition for that is when your power is a negative number. When your power is a negative number. When your power is a negative number. Please take note of that. What do I mean? This is what I'm saying. Now, when you have your expression to have a negative power, please take note, you can't use Pascal's triangle. So which means if I have x minus y, say raised to the power of what? Raised to the power of minus 2, for example, right? You can't use your Pascal's triangle. Also, if you have your power to be a fraction, so I have something like this, you can't also use your Pascal's triangle for this kind of what? For this kind of questions. What you use is you use your combination method. It's very simple. Use your combination method. Let's try this negative one while you try the fraction ones using the combination method. Trying these negative ones using combination method. Let's go. First thing is minus 2 combination of 0, right? Your first term, which is x, is what? Is getting your what? Your power, which is minus 2. Then what? Minus 0. Please don't forget. It is this power minus what? Minus r that you have, right? Your next term here is minus y, right? Then here you have what? You have raised to the power of 0. Then hard. Next term minus 2 combination 1 multiplied by our first term is x raised to the power of minus 2 minus 1, right? Multiplied by our next term here, which is minus y raised to the power of what? Raised to the power of 1, which is our hard. Add minus 2 combination of 2, right? Then multiply by minus y raised to the power, multiply by x, multiply by x raised to the power of what? Minus 2, right? Multiply by minus y raised to the power of what? Raised to the power of our r, which is 2, right? Yeah. You can choose to stop here. You can choose to stop here. Yes. It's not even choose. We are stopping here actually. So once here for this, when you have a point where the n number and your r number are having same number. Now you're having 2 here. Though this is minus 2 and you're having 2 here. So once you get to that point, you know you are going to stop there as your number of terms. Okay? Alright, so we have this. Alright, so let's expand this. Minus 2 combination 0. Tap that on your calculator. You should have. Alright, let's do that doing combination. That's n factorial over n minus r factorial, then r factorial. Okay, so what's our n here? This is minus 2 factorial over minus 2 minus 0 factorial, then 0 factorial. This is minus 2 factorial. Minus 2 minus 0 gives minus 2 factorial, then 0 factorial. This cancels this. I have 1 over 0. This gives 1 actually, right? Alright, so which means this gives 1. This gives 1 multiplied by x raised to the power of minus 2 minus 0 gives minus 2, right? Minus 1 raised to the power of 0 gives 1. Anything raised to the power of 0 gives 1. Plus minus 2 factorial gives minus 2 factorial over minus 2 minus 1 factorial, 1 factorial, right? So this is minus 2 times minus 3 factorial over minus 2 minus 1 gives minus 3 factorial, then 1 factorial. Minus 3 cancels minus 2 factorial, and left minus 2 over 1 factorial is 1. That gives minus 2. So which means minus 2 combination 1 gives minus 2. So I have minus 2 multiplied by x raised to the power of minus 2 minus 1 gives what? Gives minus 3 times minus 1 raised to the power of 1 is still what? Is still minus y, right? Minus y raised to the power of 1 is still minus y. This is enclosed in the bracket. right? To the next term plus minus 2 combination 2, that's minus 2 factorial over minus 2 factorial and 2 factorial. This is minus 2 and minus 3 times minus 4 factorial. Minus 2 factorial is what? It's minus 4. This is minus 4 factorial, 2 factorial. Minus 4 crosses out minus 4. So here I'm left with minus 2 times minus 3 gives what? Gives 6 over 2 factorial, which is 2. 2 here 1, 2 here 3. So which means minus 2 combination 2 gives what? Gives 3. Alright, so here I have 3 multiplied by x raised to the power of minus 2 minus 4, sorry, multiplied by minus y times minus y squared times, that's minus y times minus y. Minus times minus gives plus, y times y gives y squared. Okay, so which means this gives plus y squared, right? Alright, so let's expand this. 1 times 1 is 1. 1 times this gives x is power minus 2, right? Then plus, let's expand this. Minus y times minus 2 gives 2y. 2y times this gives 2x raised to the power minus 3y, right? Plus, here I have 3x raised to the power minus 4 y raised to the power squared. Yes, lest I forgot. Yes. Now, to know the number of terms where you stop here, it is dependent on your question. The question can say, find the binomial expansion for this particular binomial to the third term. This is the third term. First term, second term, this is second term, this is the third term, right? So, which means if you are told to do beyond third term, you will still do for fourth, do the fifth, do the sixth, do the seventh. Still the same method you are following through. It's as simple as that. Do we get it? Yes. Alright, so concluding this as an answer, so we can have the expansion of this man to be equals x raised to the power minus 1. Our knowledge of indices should give us this, right? Then plus simplifying this, I should have what? I should have 2y over x cubed, right? Simplifying this, I should have what? I should have 3y squared over what? Over x raised to the power 4. And this settles our answer, right? Or you can choose to leave it as this, depending on you. Do you get it? So that's basically that. Okay? So it's as simple as this. Binomial expansion is as simple as this. I'll leave you to try for the fractions of binomials, but no problem. Let's do that together. Now, say I have my power to be a fraction. So which means if I have x, let's stop there for this.